We can. Let me get through the homework first. Okay, so let's look at this, all right? Let's think of this as a house. This triangular piece would be called a house truss. And that is a sneak preview to Unit 6 project. All right, so here's my truss. They told us that this angle right here is 25 degrees. I don't know what they want. Carlos, oh, this is a grain bin. The radius of the circle is 15. Oh, that's off too. Hi, Sydney. All right, so let me try to get another line tool. So they told us that the radius of the bin is 15. If this is 15, what is this? 15. All right, that was the first thing you had to know. He wants the roof to overhang the edge of the bin by 1 foot. So X is from here to here. This is 1 foot. All right. What should the length of X be? All right, so where's the hypotenuse? X is your hypotenuse. With respect to your 25-degree angle, what is 15? Adjacent. Therefore, what trig function will you use? So you got cosine of, how do we set up 25 equals what? 15 over x. So you're going to have x cosine 25 is equal to 15. So x is going to equal 15 over cosine 25. So Brittany, I think, did you say your calculator's backwards?
Oh, yeah.
So you're going to have to do 25 cosine, and you will have to copy that number down, and then do 15 divided by that number. So that's just a little bit more work for you. So whatever that is. Now, that is x. Is that the length of the segment he wants? What do you have to do when you get this answer? That's to here. What is this answer, by the way? 16.55. Is that how long this segment, this piece of wood's going to be? We have an inch or 1 foot overhang, so we've got to add another foot to it. So that's going to be 17.55 feet. What is the position of the side length x in relation to the given angle? That would be hypotenuse. What information do you need to find the side length of a right triangle? You're going to need one other side and an angle. Which trigonometric ratio can you use? Well, we solved it. We used cosine. So we've answered all those questions. Next. 36. Pyramids. Oh, the great pyramids. We're going to study those in chapter 11 too. All right, so my pyramids got dotted lines. Can you handle that? So we're going to come up. Oh, I cannot draw a straight line. 36, I've been told. All right, so what do we have? Inside, we've got this right triangle. And this is where you're going to be using this a lot later on. They're telling us, oh, I forgot one side. There's another side to this triangle, and it's right there. So they've told us that this angle is 52 right here. And they have told us that this whole side is 82. Now, I didn't draw a very good picture, but the center of the square, do you know what this side's going to be? 41, it does. It splits it, because if this were a true square pyramid, then, and it was a right pyramid, then that point would be at the center of the square, which means that the distance from here to here and there to there would be the same. So they want to know, I don't know what they want to know. How tall was the pyramid? So they want to know how tall. So they want to know the pyramid's height. So are these, could they take a tape measure and measure this segment? Is it outside? Okay. Could they take this measurement? Because is it along the outside of the pyramid also? So could they really go in and take that measurement? No. So this is where the trig, this is where the application comes in. With respect to 50, what is h? Opposite. With respect to 52, what is 41? Adjacent. What trig function does opposite and adjacent? So do we get a tan 52? Is it h over 41 or 41 over h? It matters. H over 41 because opposite is over adjacent. So we're going to have 41 tan 52 is equal to h. Other questions? You have to finish that, by the way. Caitlin, which one? 15. So Caitlin, you're going to help me on this one. This is 15. I got to get out of the dotted line. All right, here is our right angle. 15. So they have told us that this angle is 41, that this is x, and this is 11. What kind of segment is 11 in this triangle, Caitlin? Okay. Now, with respect to angle 41, what is x? Is this adjacent or hypotenuse or opposite? Yes, because opposite would be that segment. So Caitlin, the first thing you have to do is find the hypotenuse. The second thing is label the other two sides, and now look for the numbers. We've been given x, we've been given 41, we've been given 11. So what trig function is this? Carmen, do you have a pass? So you're going to do cosine of 41. How do you set up your ratio? Is it 11 over x or x over 11? Right. And now you solve. All right, I'm going to come back to the homework, okay, because I want to start with what we're going to do in section 8.4. Why learn something if we don't know how to use it, correct? So we had one that was a pyramid that was an application, right? We had one that was a grain bin that was an application. So today we're going to use trigonometric ratios and Pythagorean theorem to solve right triangles and applied problems. All right, so here's some important vocabulary. Angle of elevation is the acute angle measured from the horizontal to a line of sight observation of an object. So this is the angle of elevation. It's always based on the horizontal. There we go. Thank you, Kayla. So the angle of depression is going to be the acute angle made by the line of sight and the horizontal. This is the angle of depression. So we've got some guy sitting up here, and he's looking down at this boat. He's more like sitting in the tower. And his angle of depression of his eyesight is this angle. And again, this is always based on the what? The horizontal. The mistake made is people thinking this is the angle of depression. That's based on a vertical. It's always horizontal down. Now, if you were a fish here, and you were looking up to the top of that lighthouse, what kind of angle is this? Angle of elevation. If you're here and looking down, it's an angle of depression. So my comment to you is, what kind of angles are the angle of depression and elevation? What kind of angles are those? I heard it. Alternate interior. Why? Because they form a what? A what? A Z. So you see, if you wanted to use this triangle in here, the angle of depression is going to be same as the angle of elevation. So if this was 42 degrees, then you would know this is 42 degrees.
Are we still going to access like sine and everything for this stuff?
Mm-hmm. So this is the relationship. Relationship, because they're always based on the horizontal. That's between angle of elevation and angle of depression. Are alternate interior angles, meaning they will always be, alternate interior angles are always going to be what? Right. Okay, I was asked earlier. Oh, come on. Here we go.
Yeah, am I even in this one?
I don't know. Brittany, would you be my recorder?
Yeah, I do that.
Am I going to add you?
Yeah.
What if you're already in here? You see your name? Well, yeah. It's because you kept flip-flopping in my classes. I think you were in here once upon a time. And then what do I have to do? Yeah? Why? Is that wrong?
No way.
Okay. This is still, Brittany, you're still my recorder. Okay, so Jennifer is called next when I ask a question. All right, so let's look at an example of what we're going to be doing. So I'm teaching this today, and then tomorrow we're going to use a question exploration routine to, since you've been familiarized with this, to see how we unpack these problems. All right, when the sun's elevation is 52 degrees, so what do we need in this picture? Jennifer? Uh-huh. Yeah, we need to draw. What am I going to draw first? What does it say? Yeah, I need a sun. Where's the sun normally located? Okay. I mean, that sounds like a silly question, but if you put it on the ground, it's not going to work. There's our sun. When the sun's elevation is 52 degrees, a building's shadow, so what else do I need now? I need a building. So let's draw a building. Here's a building. So what is the sun doing? It's going to shine on the... It's going to shine on this building and do what? Where's the shadow, by the way? You know, you're smarter than my trig kids were years ago. We had to go outside and look at that. Okay? I'm dead serious. No, the sun's not up. All right, so where's my 52-degree angle, do you think? Keyword. Right, where the shadow and the sun meet, that is your angle of elevation. That is 52 degrees. And it says the shadow cast by the sun is 18 meters long. So is the yellow hypotenuse 18, is the building 18, or is the black 18? Okay, the shadow is 18. You just told me the shadow was on the ground. Okay. What do they want to know? How tall is the building? B. We don't know how tall the building is. So there is your triangle. What are you going to have to do for each one of these problems? Right? And draw a picture. How are you going to do this without drawing a picture? You're going to get to be very good artists. All right. So, Jennifer, you already answered. So let's see. I need to know where the hypotenuse is. Brittany? The yellow. It's the sun. So there's, I always like to identify my hypotenuse because then I know who's opposite and who's adjacent. So what is B, Leslie? Opposite or adjacent? Opposite. And then what is 18? Adjacent. So the next question goes to, I need to know what trig function we need to use. Devin? How did you get that? Opposite, adjacent. Okay, and so how is that ratio going to be set up? B over 18. From here, you all should be able to take it. So really your skill today is to draw the picture, and then the picture will give you the problem. Brittany, how do you solve? We multiply both sides by 18. So B is equal to, what did you get? 23.04. So the building is 23.0 feet tall. In Vietnam, the soldiers used a cigarette box. And did I already tell you this? Okay. Yeah, a cigarette box. And that was on our similar triangles with the shadow and what they needed to find. What is the story? I'm sorry. Okay, so we are going to a pilot flying over level ground. All right? I need an airplane. You're not going to like my airplane if I draw it. All right, we need an airplane. Image. There it is. Oh, that's a nice one too. Which one do you want?
I'd say top left.
Top left?
Clouds, yeah.
Okay, so we are going to copy.
It's plagiarism. You better cite your source.
Eh.
Yeah, did you cite your source?
No.
Plagiarism.
I'm not. Okay, now we got an airplane. So we have an airplane. We have a pilot flying over level ground. So what do you think you need to draw? Okay, first I drew a what? Now, how did I know an airplane? Okay, and what does a pilot fly? It could. You're right, I could have done a helicopter. Yeah, but it would have said hot air balloon. Okay, so what? Yeah, I could have done a blip too. You're right. So now what do I need? Did I get my pilot?
Yeah.
Okay, what else do I need?
Level ground.
Level ground. So let's get some level ground going on here. Here's my level ground. What does this pilot do? What's an altitude mean?
Elevation.
Elevation, or how high from the ground he is? Okay, so how tall is that?
Down.
That's 1,000 meters, which is the same thing as what, 3,000 feet? Sights a marker. How somebody that high could sight a little marker, I do not know. But there's the marker. Okay? The angle of what?
Pressure.
So now, how do I draw that?
That's from the tip of the mouth.
From here down, but is it this angle? No, because this is what? Vertical. The angle of depression is based on a what? Horizontal. That's the angle of depression. And what is it? 15 degrees. Now, is this 15 inside my triangle? No. How do I put it inside my triangle? Now, wait a minute. What are we going to use? Oh. I was doing really well. You're so kind, MJ. Okay, so this angle of depression is equal to what in my triangle? The angle down here, correct? Okay, not here. So what do they want? Find the distance between the plane and the marker. All right, is that distance from here to here? Or is it from here to here? Which one? Second one. Why? Marker and plane. Is the plane here? But is the marker there? Where's the plane? So we are looking for this side. Something on the ground. So what are you going to do now? Never taught trig before. So he was like, he's getting negative answers. What? Okay. So now what are we going to do? Oh, wait a minute. Let me call on somebody. All right. I need to know, McKenna, who's the hypotenuse? X. What is 1,000? McKenna? Opposite. Excellent. So she's identified what we've been given. So this person's going to tell me what trig ratio we use. Samantha? Which is? Good. So we're going to do sine of 15. And how do you set this up? Is it 1,000 over x or x over 1,000? 1,000 over x. All right, so now how do we solve this? This goes to Caitlin. So you're going to have x sine 15 is equal to 1,000. Then what? Anybody have this? $3,863 meters. He must have really good eyesight. Or maybe that marker is really, really big. Okay, was that hard? It's all about drawing the picture. Let's try another one. A straight trail. Yes.
Wouldn't it just be easier to like multiply by the 1,000? Can you do that?
What do you mean?
Like instead of by x and then dividing, you just do it by 1,000 to separate x by itself.
You want to multiply by 1,000 or divide by 1,000?
Well, yeah. Yeah.
Okay, if you were to divide by 1,000, that's going to be a 1 on top. We're going to have 1 over x, not x. Okay? So you really do, whatever's here, you've got to multiply by. All right. A straight trail leads from a campsite, elevation 3,000 feet, to a scenic overlook, elevation 42,000 feet. So where is this campsite?
Put it at the bottom right.
It's 3,000 feet up. Right? So let's mark, this is the campsite.
It said up, not. It said up, not.
A straight trail leads from the campsite at an elevation of 3,000. This is 3,000. To a scenic overlook that is how tall? So this is going to be what? This is, all of this is how much? 4,200. All right. If the length of the trail, now where do you think you're going to draw, where are we going to get our right triangle?
On the bottom.
We could do the triangle on the bottom,
Or the right.
but that doesn't help me with campsite, does it? And they're telling us that the length of the trail starts at the campsite. So we're going to have to do this. There's my right triangle. Which is the trail? Which one is the trail? The horizontal, the vertical, or this one? This is the trail. This is 16,000 feet. All right, this is inside the cliff. This is inside underground. How do you figure out how long this is? Okay, how did you get 1,200? Okay, do you see that's 3,000? Yes? So what must this be? 3,000. And if the whole thing's 4,200, what must that be? 1,200. What is the inclination, new word? What do you think they're asking us for? Incline.
Elevation.
It's like the angle of elevation. So we're asking for this angle right there. All right, so I need to know, where's the hypotenuse, Trevor? Okay, so what is 1200? Opposite. I need to know what trig function we're going to use. Kayla S? Right, because we have opposite and hypotenuse, so we're going to say sine of the unknown angle. How do you set up this side? Look at your notes and tell me whether it's hypotenuse over opposite or opposite over hypotenuse. 1200 over 16,000. All right, how do we go about solving this? Because now the angle's unknown, Harper.
Multiply by 16,000.
We got to get the angle away from sine. So we can't use the sine button on our calculator because we don't know the angle. Sine what?
Oh, sine.
Inverse. So we're going to sine inverse both sides. Sine inverse of sine is x. So now I need to know what sine inverse of 12,000 divided by 16,000 is. Calculator users? 1,200 divided by 16,000. Say that again? 4.30. Okay, so that is our angle of inclination, also known as angle of elevation. I like these problems because you can draw. Do you like these problems? It's a lot of work. Really, it's not very much work when you get to the equation.
Yeah, I know. But stop, draw out.
Okay. So to start this one, what do you think we're going to need to do? What will we draw first? I can't get this to go.
There it is.
Travis? What do I need to draw first? What does it say? What is that? So what do we have to draw? An isosceles triangle. Do you all remember what an isosceles triangle? Two equal sides, and I'll go ahead and mark these as my two equal sides. Next question. Two or more, yes. Which angles are the bases? So let me label this A, B, C. What are the bases? A and C, the ones opposite the equal sides. They measure 52. If the base of the triangle is 18, which side is the base? Bree? So that's going to be AC, the one that's not the equal sides. So that is 18. Find the length of the altitude. Now, we studied altitude. How do I draw an altitude? Trevor?
Oh, it goes from angle to
So an altitude has a perpendicular relationship. In an isosceles triangle, what just happened to 18? It got bisected. All right, so this is 9, and Devin did answer that question. Find the length of the altitude. So which segment should I put my variable on, Jeff? The dotted line or the solid line? Dotted. All right, so with that said, can you identify the hypotenuse of the right triangle on the right-hand side, Jeff? So what we're doing right now, we'll put, the horse in its blinders. Let me kind of put this, I'm going to hide this. Okay? There. No, that didn't work. That wasn't fill. Oh, you're right.
You just made the white. You just made the lines white.
There we go. There we go. Okay. So focusing on this, where's the hypotenuse? BC, exactly. All right, so he's identified the hypotenuse. That is x. I need to know what the other two segments happen to be. Brittany N., what is x with respect to 52? Adjacent means next to? Right. So this is opposite, and then what is 9? Right. See, we need to identify the hypotenuse because we can't call it adjacent. Hypotenuse is special. So now the question comes, what trig function involves opposite and adjacent? Brittany? What trig function now? Tan. And how do you set up, it's going to be tan 52, how do you set up this other side? X over 9 or 9 over x? Give her a minute, let her look it up. She was absent yesterday. Excellent. X over 9. So now how are you going to solve these? Trevor?
Then you would multiply by 9.
So 9 tan 52 is 1152? What do you think? Did you?
Yeah.
I think Brittany did too. Is Brittany my recorder?
Yeah.
Okay, so let's look at this one. A rescue worker is located 175 feet above the ground in a what? So what do you think we need to draw? A lighthouse. So here is my lighthouse. Let's put a little circle on top. This is my lighthouse. See, it's got light inside it. Oh, sorry. That's not light. It's got light. There's my lighthouse. A rescue worker is located 175 feet above the ground. Can you tell me where that number goes?
There.
Do you agree that these... So we got this worker in here. See him? He's in there. So it says he spots a ship. So now we need a ship. There's the ship. It's a small one. He spots a ship on the water at an angle of depression of 62 degrees. Where is his line of sight? From his eye where? To the boat. Now, what kind of angle was it? Depression. The question is that this angle? Angles of elevation, depression are always based on the what? Horizontal. And what is this? Vertical. So we have to look at the horizontal, and the angle of depression they're talking about is right there, which is 62. All right, here's the water. So if that's 62, what else? Oh, we got green water. Okay, so it's got algae in it. Yeah. So where else is, what other angle 62? The one by the ship, because they are alternate interior. How far from the base of the lighthouse? Is that this segment or this green segment? Base of the lighthouse. He is up in top of the lighthouse. This is the base. We do not know. Is the ship? We do not know. So that's going to be X. So Samantha, where's the hypotenuse? Yes, this is our hypotenuse. So with that identified, I need to know opposite and adjacent. So which sides are opposite and adjacent, Karen? With respect to this angle down here. X is adjacent and the other one's opposite. So with all of this identified, what's going to be my trig function, Sydney? Tan. And how do you set that up? Who's on top? Opposite over adjacent. So this is a little bit more work than most. What do we have to do, Samantha? Multiply both sides by x. Once we do that, what are we going to have to do next? Kayla? divide by tan 62. So if you get stuck tonight, what are you going to do?
Look at the notes.
Listen to the notes